This is a solution to question number 16 on page 516, chapter 18 of the textbook. The question reads, a certain copper wire has a resistance of 10 ohms. At what point along its length must the wire be cut so that the resistance of one piece is 4 times the resistance of the other piece? What is the resistance of each piece? For starters, we should start by recognizing that resistance is proportional to length. So we kind of can take a look at this resistivity equation. Resistance rho, which is a function, it's a physical property of the material. So it's the resistivity of the material, length of the wire over the cross-sectional area. So we can see that both of these other pieces aren't changing. The cross-sectional area of the wire is not changing as we kind of move down the wire, and either is the material composition of the wire. So the length and the resistance are directly proportional. And so we can start this problem by saying that the length of the wire is going to be the length of the short piece of the wire plus. And we also know that the length of the short piece needs to be 4 times, the length of the long piece needs to be 4 times the length of the short piece. So I can kind of set this up and say that, let me use my eraser. This is sloppy. I can say that 4 times the length of the short piece is equal to the length of the long piece. Okay, so now I'm going to kind of use this and plug this expression in here. So now I can say, all right, well, the length of this piece of wire is going to be the length of the short piece plus 4 times the length of the short piece. And now I can say that the length of the wire is equal to 5 times the length of the single short piece. We know the length of the total piece is then going to be 1/5 or 20%. So I can basically divide both sides by 5 and say that the total length divided by 5 is going to be equal to the length of the short piece. Or we can say, that 0.20 times the original length of the wire is the length of the short piece. And then, of course, 80% of the length of the wire, the remaining balance, is going to be the length of the long piece. The follow-up question asks you to figure out the resistance. I think there's a lot of ways of kind of doing this formally, but if the resistance of the wire is 10 ohms, using this expression here, we can see, hey, 20% of the length is going to be 20% of the resistance. So the short piece is going to have a resistance of 2 ohms. And I should say the resistance of the short piece. And the resistance of the long piece is going to be the balance of that, or the 8 ohms.